Have you ever wondered if our universe is older than the Big Bang? Recent discoveries by the James Webb Space Telescope are turning our understanding of the cosmos upside down. Welcome back to our channel. Today, we're diving into groundbreaking revelations from the James Webb Space Telescope that have left scientists and astronomers scratching their heads. Could it be that the universe is much older than we thought? Let's explore these astonishing findings together. As many of you know, early and massive galaxies that defy our standard cosmological model have been a hot topic in astronomy. Scientists were eagerly awaiting more discoveries of such galaxies in the distant universe to confirm a brewing crisis in cosmology. Finally, after all the anticipation, the James Webb Space Telescope has delivered a shockwave discovery. A massive, bright galaxy that appears to be older than the Big Bang itself. This unexpected revelation is shaking the foundations of our understanding of the universe. If galaxies existed before the Big Bang, it suggests that the universe did not begin 14 billion years ago, as we have long believed. The discovery has scientists worldwide in a state of concern, as the Webb telescope continues to uncover more and more massive galaxies in the early universe. So, what exactly did the Webb telescope see in this ancient universe? The telescope recently set a new record by detecting the most distant known galaxy, named Jade's GSZ 14. This galaxy breaks the record held by another Webb telescope discovery, Jade's GSZ 13, from last year. Jade's GSZ 14 is observed as it was just 290 million years after the birth of the universe. If the universe is 13.8 billion years old, this means we're seeing the galaxy when the cosmos was merely 2% of its current age. What makes Jade's GSZ 14 so fascinating is not just its great distance but its size and brightness. This galaxy spans over 1,600 light-years across and is 5 times brighter than its predecessor, Jade's GSZ 13. Unlike many luminous galaxies, whose brightness comes from gas falling into supermassive black holes, Jade's GSZ 14's light is believed to come from young stars. Webb astronomers Stefano Carani and Kevin Hanline from the University of Arizona suggest that this amount of starlight implies the galaxy is several hundreds of millions of times the mass of our Sun. This raises a perplexing question. How could such a bright, massive galaxy form in less than 300 million years? Another intriguing find is the significant amount of oxygen present in Jade's GSZ 14, indicating that the galaxy is already mature. For oxygen to be visible, multiple generations of massive stars must have lived and died, spreading the element across the galaxy. How this happened so quickly is a hot topic among cosmologists. These observations suggest that galaxies formed much more rapidly than our current models predict, challenging our understanding of galaxy evolution and the timeline of the early universe. The existence of these massive, luminous galaxies implies that either the universe is older than we think or our models of its early evolution are fundamentally flawed. Previously, the Webb telescope had already stunned astronomers by showing that the universe's expansion rate is not uniform, and matter distribution is not isotropic. These findings have already upended key cosmological theories, and the discovery of these distant bright galaxies has added to the puzzle. Several hypotheses have emerged to explain these anomalies, each pushing the boundaries of our current understanding of cosmology. One of the most intriguing ideas comes from Nobel laureate Roger Penrose, who proposes the existence of a universe prior to our own. Penrose's conformal cyclic cosmology (CCC) model suggests that the universe undergoes infinite cycles of Big Bangs and subsequent expansions and contractions. In this model, each universe, or eon, gives birth to the next through a singularity at the end of its life cycle, leading to the beginning of the next Big Bang. This theory implies that our universe is just one in a series of endless cycles, with evidence of previous universes potentially observable in the cosmic microwave background (CMB) radiation. The CCC model is fascinating because it challenges the conventional view of the universe's timeline. It suggests that time did not begin with our Big Bang but is instead part of an eternal sequence. Penrose argues that certain anomalies observed in the CMB, such as unexplained patterns and concentric circles, could be imprints from black holes in previous universes. These features, often referred to as Hawking points, named after Stephen Hawking, are proposed as remnants from the end of a previous eon, providing potential evidence for the CCC model. Another hypothesis that has gained traction is the concept of multiple universes, often referred to as the multiverse theory. This idea suggests that our universe is just one of many that exist simultaneously, each with its own distinct laws of physics and constants. The multiverse theory offers a potential explanation for why our universe seems fine-tuned for life and why we observe certain anomalies in cosmological data. If there are countless universes, it stands to reason that some would naturally have the conditions necessary to support life as we know it. Within the multiverse framework, there are several different models. One is the bubble universe model, which posits that new universes are constantly being formed through a process called eternal inflation. In this model, different regions of space undergo rapid expansion at different rates, creating bubbles that each become separate universes. These bubble universes could have varying physical constants and properties, explaining why our universe appears uniquely suited for life. Another multiverse model is the brane world theory, which arises from string theory. This model suggests that our universe exists on a three-dimensional brane, floating in a higher dimensional space. Other branes, each corresponding to a different universe, could exist parallel to ours. Interactions between these branes could potentially explain certain cosmological phenomena, such as the uneven expansion of our universe. Recently, a groundbreaking study published in the Journal of Cosmology and Astroparticle Physics proposed an even more radical idea: that the expansion of our universe might be due to it constantly merging with other universes. This theory, developed by physicists Jan Ambjorn, Jerzy Jurkowicz, and Renata Loll, posits that our universe is not isolated but is part of a dynamic multiverse where mergers between universes are common. The authors of this study suggest that the accelerated expansion of our universe, often attributed to dark energy, could instead be explained by these mergers. As our universe collides and merges with other baby universes, it could experience bursts of accelerated expansion. This model provides a compelling explanation for why the expansion rate of our universe appears to vary in different directions, a phenomenon that has puzzled astronomers for years. To support their theory, Ambjorn and his colleagues conducted detailed mathematical simulations. Their calculations showed that the rate of expansion in a universe undergoing frequent mergers would align more closely with observational data than the traditional cosmological model. This suggests that the merging universe hypothesis could potentially solve one of the biggest mysteries in cosmology, the nature of dark energy. Moreover, this theory could also explain the rapid formation of early massive galaxies, as observed by the James Webb Space Telescope. If our universe has been merging with other universes, the influx of matter and energy from these collisions could have spurred the rapid growth of galaxies. This would account for the presence of large, bright galaxies in the early universe, which current models struggle to explain. In conclusion, the recent anomalies observed in the early universe have prompted scientists to explore a wide range of hypotheses. From the existence of prior universes and multiverses to merging universes and modifications to fundamental physics. Each of these theories offers a unique perspective on the complex and enigmatic nature of our universe, pushing the boundaries of our knowledge and challenging our understanding of cosmology. As we continue to probe the depths of space, we can only anticipate what other astonishing discoveries await us in this vast and ever-evolving cosmos. So, why is the universe so confusing? These new findings have left us with more questions than answers. What do you think about these discoveries? Share your thoughts in the comments below. If you enjoyed this video, please give it a thumbs up and subscribe for more cosmic updates. Thanks for watching, and see you next time.